Okay, today we're doing the bookwork for completing the square 9-5. We're spending a second day on this because this is a little bit of a more challenging skill. Now, the problems in your book aren't totally going to correlate with what I'm writing on the paper here. I'm changing the problems up a little bit to keep it simpler since we're doing online instruction right now. So if you have your book open, just keep that in mind. Okay, so take these notes, take out a piece of paper, pause the video so you can kind of catch up on what I have down so far. Okay, so completing the square. To review, completing the square is the process of adding b divided by 2 squared to x squared plus bx to form a perfect square trinomial. This method is useful when a quadratic expression is not factorable, but it can be used for any quadratic. Okay, so the first question asks us, what value of c makes x squared plus 6x plus c a perfect square trinomial? So what we need to do is we need to take half of this middle term and square it. So half of 6 is 3, and 3 squared is 9. So it's x squared plus 6x plus 9. Our value of c is 9. Okay? And then if it asks you to write, it's going to ask you this in the homework, write as a binomial squared. All that means is that you need to factor it. Okay? So if I wanted to write this as a binomial squared, it would be x plus 3 squared. All right, next. Do the try-its on your own. Pause the video. Half of 12 is 6. 6 squared is 36, so c equals 36. If I'm writing it as a binomial squared, it would be x plus 6 squared. This one, half of 8 is 4. 4 squared is 16, so c equals 16. If I'm writing it as a binomial squared, it would be x plus 4 squared. Okay, moving on to example 2. So this is reviewing from yesterday, completing the square. So solve x squared plus bx equals 0. So the first equation is x squared minus 14x plus 16. We're going to take half of our middle, first before we take half of our middle term and square it, we have to first move over the 16, because remember we always move over our constant term first. So I'm going to subtract 16 on both sides. Now I have x squared minus 14x equals negative 16. Next step, take half of b and square it. Half of negative 14 is negative 7. Negative 7 squared is 49, so I'm going to add 49 to both sides. That's going to give me x squared minus 14x plus 49 equals 33. Now I'm going to factor this. It factors to x minus 7 squared equals 33. Take the square root of both sides. X minus 7 equals plus or minus radical 33. So our two solutions are x equals 7 plus radical 33 and x equals 7 minus radical 33. Do the next one on your own. Okay, so we are going to move over our constant term. Add 9, add 9. X squared plus 10x equals 9. Half of 10 is 5. 5 squared is 25, so I'm going to add 25 to both sides. X squared plus 10x plus 25 equals 34. This factors to x plus 5 squared equals 34. Square root both sides. X plus 5 equals plus or minus radical 34. Nothing we can do with that radical. We keep it like that. Subtract 5, subtract 5. X equals negative 5 plus radical 34, and x equals negative 5 minus radical 34. Those are our two solutions. Okay, moving on to example 3. This is something that a lot of us, I almost slow down. Okay, this is something that a lot of us have had some trouble with yesterday. Complete the square when a does not equal 1. So when the leading coefficient isn't 1, that's a problem. You actually have to get the leading coefficient to be 1 before you complete the square. You have to, or you will get the wrong answer. So what we're going to do, to make this a 1, we have to divide everything through by 2. You always divide through by the leading coefficient. So this becomes x squared minus 12x minus 2 equals 0 divided by 2 is 0. Now I'm going to move over my constant term. X squared minus 12x equals 2. Half of negative 12 is negative 6. Negative 6 squared is positive 36, so I'm going to add 36 to both sides. That gives us x squared minus 12x plus 36 equals, add 36 to both sides, and that makes 38. Equals 38. I'm going to move up here. Now I'm going to factor this, so it factors to x minus 6 squared equals 38. Take the square root of both sides. X minus 6 equals plus or minus radical 38. Add 6, add 6. Our solutions are x equals 6 plus radical 38 and x equals 6 minus radical 38. Try this one on your own. Remember, divide through by that leading coefficient first. Okay, so this one, divide by 2, divide by 2, divide by 2, divide by 2. X squared plus 14x plus 18 equals 27. Move over the constant term. Subtract 18, subtract 18. X squared plus 14x equals 9. Half of 14 is 7. 7 squared is 49, so I'm going to add 49 to both sides. X squared plus 14x plus 49 equals 58. Factor x plus 7 squared equals 58. Square root both sides. X plus 7 equals plus or minus radical 58. Subtract 7, subtract 7. Our two solutions are x equals negative 7 plus radical 58 and x equals negative 7 minus radical 58. Okay. Example 4, convert from standard form to vertex form. There's two ways of doing this. The first way, we're going to complete the square, and the second way, we're going to kind of revert back to an older method that we've learned, we're very familiar with. So we have learned how to convert from vertex to standard form. That was when you had to like FOIL and expand it out. So now we're converting from standard to vertex, which is quite a bit different. You're going to start the same way. You need to move over your constant term. So our constant term here is 11. That's our C. So we have to move that over. So we're going to subtract 11 on each side. We have y minus 11 equals x squared minus 8x. Half of b, so half of negative 8 is negative 4. Negative 4 squared is positive 16, so we're going to add 16 to both sides. That gives us y plus 5 equals x squared minus 8x plus 16. This side factors to x minus 4 squared. Okay, and then this stays as y plus 5. Now you might want to start taking the square root of both sides, but we're actually not going to do that. We're trying to get to vertex form, and remember, vertex form is y equals a times x minus h squared plus k. So all we have to do now is we have to subtract 5, subtract 5, and that gets us y equals x minus 4 squared minus 5. Now it's in vertex form. So your goal is to get y by itself, and to do that you just got to move the 5 over. So it's a little bit different than completing the square because the last step is different. But as you can see, this is vertex form now, right? Vertex of 4, negative 5. Okay, now second way to do this is by doing x equals negative b over 2a. The book does not show you this, but I am showing you this because once you get to when you have a leading coefficient that's not 1, it's really hard to complete the square with it with converting between standard to vertex form. So what we're going to do is we're going to do x equals negative b over 2a. Remember, this is how we find our vertex. So x equals negative 8 is positive 8 over 2 times, this is a 1 here, right? So x equals 8 over 2, so x equals 4. Okay, now that's our x value of our vertex. To find our y value, we need to plug back in. So y equals 4 squared minus 8 times 4 plus 11. Y equals 16 minus 32 plus 11. Y equals negative 5. So now we know that our vertex is 4, negative 5. And we can go right into vertex form, which is y equals, or f of x, whatever you want to write, a times x minus h squared plus k. That's vertex form. A is 1, right? Because this is our a here. That's where a is. So we don't have to write a 1. We can just keep it like that. X minus, remember, hk. So h is 4 plus, well, plus negative 5 is really just minus 5, right? So k is your y value. So that's it. So as you can see, we got the same answer both ways. I like this way better, except for when the leading coefficient is not 1, which I'm going to show you in this example down here. Wow, this video is pretty long. Oh well. Okay, next. Try this one on your own, see how it goes. I would complete the square for this one, use that first method. Okay, so we're going to move over our constant term, subtract 3, y minus 3 equals x squared minus 2x. Half of negative 2 is negative 1. Negative 1 squared is positive 1. Adding positive 1 to both sides. Y minus 2 equals x squared minus 2x plus 1. Factor x minus 1 squared. Don't take the square root of both sides, just move this over. So now we have y equals x minus 1 squared plus 2. Okay, that's the first method. Now, I would use the second method for this one because you have a leading coefficient of 3. If you try the first method, it's very difficult. Okay, so for this one, we're going to do x equals negative b over 2a. Negative b over 2a. So x equals, so negative b, that's positive 30 over 2 times a is 3. So x equals 30 over 6. So x equals 5. To find our y value, we're going to plug this back in. So y equals 3 times 5 squared minus 30 times 5 plus 71. Y equals 3 times 25 minus 150 plus 71. And and y equals 75 minus 150 plus 71. And 75 minus 150 is negative 75. Negative 75 plus 71 is negative 4. Okay, so now we have our vertex as 5, negative 4. We're going to plug into vertex form. Y equals a times x minus h all squared plus k. A is 3, okay? We know that. Y equals 3, x minus, so this is your h, this is your k, 5 squared minus 4. And that is that. Okay, so you're going to do some practice and problem solving questions now in your book. I will post what I would like you to do. Have a great day.